So here's another example of a kind of problem we could do that's fairly straightforward. It is asking me, it's giving me a particular function, this one here, 3e to the x minus 5x, and it asks for what values of x does this graph have a horizontal tangent. So you know what we have to do. We have to take the derivative because that'll give me the slope of the tangent line, and we want to set the derivative to 0 because that will let us figure out where the horizontal tangent is. Okay? So f prime of x, derivative of e to the x is e to the x. Derivative of 5x is just 5, rather minus 5, right? Minus 5x, so it's minus 5 because derivative of x is 1. There we are, and we set this equal to 0. And I solve, right? E to the x equals 5/3. Take the natural log of both sides, gives me x is natural log of 5/3. And that's the answer. That's the value of x at which this graph has a horizontal tangent. That's all I was asked. It was easy. There was not much work to do. Sometimes there'll be more work, though. So I have another one here, which is a little bit more work. This one is also about tangent lines, but they made it a little bit more complicated. They say, find equations for two tangent lines to the function, right, to the curve. Y equals x cubed minus 3x squared plus 3x minus 3 that are parallel to the line x minus y equals 15, I think it was. Okay. So in other words, here, let me just show you a picture. I thought I had this set up. Hold up. Might not be set up. Oh, it's not set up. Oh, maybe it is. Hold on. Oh, there it is. So here's the function. I graphed it. And here's the line they gave you, right? As you see, these aren't, the line they gave you is not tangent to the function. It's a little bit off to the side. But what they want is they want two lines parallel to the blue line that are tangent to the function, right? So it maybe is going to be somewhere around here and somewhere around here. Well, we have to figure it out, right? We have to calculate it. So what you do know about parallel lines is that they all have the same slope, right? So they gave me this function, 3x minus y equals 15, this line, or if I rewrite it, y equals 3x minus 15, right? So that line, the blue one in the picture, has slope 3. So what we're going to need is we're going to have to find the derivative here and find x values that also have the slope 3. Okay? So that's the idea. Here, let me just write that here, m equals 3. That's what we're looking for. Other lines with slope 3, but lines also that are tangent to the curve. So let's see, if I take the derivative, I've got 3x squared minus 6x plus 3, right? Just go ahead and use the power rule. Now I want to let that equal 3. So I want x's that give me the derivative being 3. Right, so this is easy to solve, right? The 3's cancel. I have 3x squared minus 6x equals 0. I pull out a 3x, x minus 2 equals 0. So I have two possibilities, x equals 0 and x equals 2, which is great because they told me I was looking for 2 tangent lines. Fantastic. So now I have the slope, I have the x values, but I still need the y value of the point, right? Because I'm going to use my point slope formula, so I need the x and the y value. So I can go back, though, to my original function and find the y value that corresponds with these x's, right? So the first one is easy enough. When x equals 0, y equals -3. The second one, when x equals 2, y equals, what do I have here? 8 minus 3 times 4 plus 3 times 2 minus 3. So 8 minus 6, 2 minus 3 gives me -1. Yep. So those are my 2 points, right? 0, -3, and 2, -1. Or maybe I'll write them over here because and now I want to find the equations of the lines. 2 lines with slope 3 that both go through those, well, each goes through one of those 2 points. All right, so get rid of this. And then first one's going to be y minus y naught is 3 times x minus x naught. That's going to give me y equals 3x minus 3. The second one would be y minus y naught is 3 times x minus x naught. So that's going to give me y equals 3x minus 6 minus 1 minus 7. Okay. So let's see what those look like on my graph. Because I had put them in here. And so there's one of them, and there's the other one. All right. So you see that now you have a sort of a visual picture of what's going on. We found the 2 points that gave us these 2 lines parallel to the line that we were given. So it was a lot more steps than the previous one, but eventually the idea is the same. They are asking us something about the function by asking us something about the tangent line.